Titanium, among the strongest metals on the planet. Good day, my name is Andile Mazibuko, and the title of my talk is Evaluating the Geometry of Titanium Ti7 Cluster in Ti03 Medium. Now, why is titanium so significant? This is due to its low density, high strength-to-weight ratio, biocompatibility, as well as excellent corrosion resistance. As such, titanium is applicable in aerospace industry, in turbines, medical industry, in surgical instruments, and automotive industry in titanium springs. Now, titanium can be produced in its metal and powder form through the Kroll process, which involves the reduction of TiSl4 with magnesium, as shown in this illustration of the main processing parts of the Kroll process. However, this process occurs extremely fast and results in the formed Ti deposits adhering to the reactor family. Now, the main purpose of my research is to use computational modeling techniques to investigate the interactions of a stable Ti7 cluster in TiCl3 medium. This is done in order to seek an understanding on how various entities can influence the reaction mechanism and how titanium production can be enhanced. Now, in this research, we used a molecular dynamic approach, which is a computer simulation method used for analyzing the physical movements of atoms and molecules, and is also used to check the temperature and pressure effects. Now, we employed a popular molecular dynamic code, the Delphi code, which can be used in understanding the structure, stability, and reactivity of ceramics, minerals, as well as can be used to simulate very large systems. Now, we use the code to perform temperature dependence calculations, employing a canonical NVT ensemble radial cutoff of 9.95 angstroms using a core count of 48 and 24-hour wall time on a normal queue at the CHPC. We then went on to analyze our results. Now, the diffusion coefficient was investigated in order to understand the motion of TiCl and Ti7 ions in the structure, as well as to trace the trajectories of these ions. Now, figure 1 shows the diffusion coefficient plot for the interaction of Ti7 with the P-31M TiCl3 polymorph. Now, the curves show an exponential increase in the diffusion coefficient rate as temperature increases. However, the Ti7 ion diffuses faster at high temperatures, that is, from 1050 kelvins to 2000 kelvins. Now, this suggests that Ti7 cluster is favorable at high temperatures, which are temperatures greater than 1050 kelvins. We then went on to look at the geometry of the cluster after interactions with the medium. Now, this was done to investigate the effects of the medium on the Ti7 cluster at different temperatures. We observed that the cluster still has its reported stable geometry of pentagonal bipyramid, as shown by the insights on the diffusion coefficient plot. Now, this suggests that the medium does not affect the stability of the cluster. Now, table 1, we observed that the bond size decreases. However, there is an elongation of Ti7 bonds from 2.503 angstroms at 50 kelvins, which is low temperature, to 2.572 angstroms at high temperature, which is at 1100 kelvins. Now, the bond length A, B, C, and D are indicated on the nanocluster, which is the insect on the bottom left corner. Now, the pure theoretical and ground state values as shown in table 1 are added for comparison. Now, in conclusion, we investigated the effect of TiCl3 P-31M structure on the Ti7 cluster at different temperatures. Now, the diffusion coefficient results show that the Ti7 cluster diffuses faster at high temperatures, which is between 1050 kelvins to 2000 kelvins. Now, the cluster was observed to maintain its ground state pentagonal bipyramid geometry at all temperatures. However, the Ti7 bonds in the cluster contract. Now, the findings of this study suggest that the P-31M promotes contraction of the cluster and provide more insight into using TiCl3 medium as an alternative medium in the production of titanium. I would like to acknowledge the following funders and institutions. Thank you.